Okay, we're going to combine two lessons here, and we're going to look at Notes 2.6 and Notes 2.7. It won't take us very long. There's one thing we want to look at in 2.6, and it's talking about, can I find a unit rate? So I just want the definition that is printed there of a unit rate, and it means per one. So I want to talk about some real life examples of unit rates. You might see where it says like $2.15 per 1 gallon of gasoline. Per gallon of gas. That's an example of a unit rate. So it is a price per 1 gallon, or maybe we can look at the speed limit, 70 miles per hour. That is a unit rate, meaning you're going 70 miles in 1 hour, per 1 hour. But what happens, let's say that we want to go buy maybe some Sprite or some kind of soda, and what if I tell you that a 12-pack of Sprite is $3.99. That is not a unit rate. Okay, what if I wanted to find out how much it was per 1 can? Per 1 can. So we can look at what we're paying per 1 can. So what we would do is we would divide. We want per 1 can. So we're going to divide by the cans. And so our price would go in the numerator. And so if I take $3.99 and I divide it by 12, we would find out that our unit rate for this example would be 33 cents per 1 can. So do you ever wonder why you buy a can of soda out of a vending machine and it costs you $1? They're making money off ya. So we can take and we can find unit rates by dividing to figure out how much it would be per 1 unit. Let's look at one last example. Okay, if someone paid $472 for 5 nights stay at a hotel. How much would it cost for 1 night? Well, we could find out by dividing our $472 by the 5 nights. And we would get that our hotel for 1 night was $94.40 per 1 night. Per 1 is your unit rate. So I just wanted to take a quick couple minutes to review what a unit rate is. I'm sure I know you had a unit rate in 6th grade and 7th grade as well. Let's go ahead and we're going to now change our thinking and go into notes for 2.7 and look at those. And 2.7 notes are talking about proportions and we're going to try to see if we can apply and solve proportions. And so first of all, we need to know that what is a proportion? And it's 2 ratios that are set equal. Okay, and let's get written down that there are 3 ways to write a ratio. Three ways to write a ratio. We can use the word to. We can use a colon. Or we can use a fraction. So we can use the word to, we can use a colon, or we can use an actual fraction. And since we know that two ratios are set equal, most of the time you are going to see proportions written as two fractions set equal. So let's go ahead and jump into an example that I think you're going to be able to figure out here. So example 1. If I have 5/9 equals 15 divided by x. This is two fractions set equal, so we have a proportion here. And for this specific example, because yes, it has an equal sign, we know that the left fraction has to be equal or equivalent to the right fraction. So we could try to ask ourselves, how do we go from 5 to 15? We multiply by 3. So if we're going to create an equivalent fraction here, how do you think I could find my value for x? Well, keep it equal. We would have to multiply my 9 by 3. And so my x for this example would equal 27. Now that's not always going to work. Okay, that is not always going to work. So let's go ahead and take a look at my next example. Example 2 here, let's say I have 7/8 is equal to m divided by 12. Because my m is in the numerator, one way that I could solve this example to get m all by itself is the inverse operation of divide by 12 would be to multiply by 12. The reason we can't figure out what 8 times what equals 12 is we know it's not going to be a whole number. So that method doesn't work for this like it did for the first example. So when we undo that division, we multiply. We have m by itself, and we know 12 we can make as a fraction by placing it over 1. So 12 times 7 is 84. 1 times 8 is 8. And so my answer here is 84 divided by 8. That is your value for m. Now, we could simplify that. How many times does 8 go into 84? Well, we know 8 times 10 is 80. So it'd be 10 with 4 8s left over, also known as 10.5. So that is your value for m. All of those mean the same thing. The top one is an improper fraction, and the bottom one is the most simplified fraction. I always like, if our answer becomes a fraction, leave it in fraction form, simplified. We know that 10.5 or 10 5/10 is the same thing as 10.5. So I just showed you a lot of different ways to write this, and I'm sure your teacher will discuss the way that they prefer. This is my preferred method. Simplified fraction. Don't be afraid of fractions. They're our friends. So I want to show you another method that will always work. The first method we know doesn't work always. This method is only going to work if your letter is in the numerator. So let's talk about a method to solve for our variable if we have a proportion. It will always work. And so this example, we'll call it example 3. And we have 5/8 equals I'm thinking here, sorry. 5/8 equals, we'll just go with 10 over x. Yes, I know you can probably do this one in your head. I didn't make it too tricky. Should have made it trickier. But I want to show you, since you can do this in your head, it's a good one to practice on. We can use what we call cross multiply. So I'm going to show you how you can cross multiply when you have two proportions, two fractions set equal. And so when we cross multiply here, we take our numerator and we multiply it by our denominator on the opposite side. And 5 times x is 5x. And we set that equal to cross multiplying the other direction. 8 times 10, which is 80. And then we can just solve for our x. 5 times x, the inverse is divide, so we get x by itself, and we get 16. Cross products, cross multiplication will always work. Let's do one more of those using our cross products. How about we look at 2/3 equals 15 over a. And I'm even going to show you that we can go the opposite direction here. 3 times 15 is 45. 2 times a is 2a. 2a and 45 is the same thing as saying 2a equals 45, which is why it doesn't matter which way you multiply by first. Doesn't matter the way we write it. The inverse of 2 times a would be to divide both sides by 2, and a is 45 halves. Now let's think about it. How many times does 2 go into 45? Well, we know 22 times 2 is 44. So it's 22 and 1/2. The last example we want to be really careful with.